All right, review for the last grade worksheet. Identify the explanatory variable and the response variable. So remember, we always say y depends on x. Okay? Explanatory is always our x, response is our y. If it helps you remember, x comes before y in the alphabet, e comes before r. So, the old trick with domain and range, same thing. So x is explanatory. Also, you might think about explanatory has an x in it. Another way to remember it. Okay? So, I know it has a y in it too, but whatever helps. So explanatory and response. So y depends on x. So a college counselor wants to determine the number of hours spent studying for a test can be used to predict grades. So does the number of hours depend on the test, or does the test depend on the number of hours? The test depends on the number of hours. So test score depends on the number of hours studied. Okay? The test scores are dependent on how many hours you study. Theoretically. Yes, you can study and still do poorly, but generally, the more you study, the better you do. So the response, test scores, depends on the explanatory hours studied. Okay, so now we're going to talk about whether or not there's a positive, negative, or no correlation. So remember, positive, yep. Positive looks like this, you know, as like time goes, something increases. Negative would look like that. And no correlation would be just kind of scattered, no correlation. There's no line in there. Okay? So, number of hours of driver's education completed and your score on your driver's license test. As you study more, take more hours of driver's ed, do you expect your score to go up on the test or down on the test? Up. Okay? So that's positive. You just want to put a plus sign, you can do that too. Now, this one can be confusing, age and income. This is not individually. Like, individually, you expect as you get older, you're going to get raises and make more money than you did when you were younger. Yeah. But this is in general. Does someone's age predict their income? No, there's no correlation. So remember, you're not looking individually. Yeah, of course. I make more money than I did when I was 17. Okay? A few years from now, I'll make more money than I do now. You get raises. But it's not talking about an individual. It's talking about, is there a correlation between anyone's age and their income? Not necessarily. There are people younger than me that make more money than me. Okay? There are people older than me that make less, so there's no correlation. Gender and hair color. Well, that's no correlation for two reasons. One, there's just no correlation. And two, they're not numbers. Okay? X and Y, when we're talking about correlation, have to be numbers. Those are categorical things. So, no connection. Supply of a product and the price of the product. So as you get more and more product, so if a company has over product, what do they do to the price? Do they raise the price or lower the price? Lower the price. So this is a negative correlation. Or you just put a big one negative sign. All right, now we're going to make a scatter plot for this data. And we're going to be using this data for the rest of the packet. So make a big old XY. We're going to put our hours down here and scores over here. Hours range from 2 to 8. So we pretty much just go 1, 2, 3, 4, 5, 6, 7, 8. You don't have to number every one, you go every other one. And our lowest number is 60 on scores, and our highest is 90. So remember, we're not going to start at 0, because that's kind of silly, because we're going to have this huge empty space. So remember, you can just put that little zigzag thing here to show that we're not going to start at 0. And just put 60 here, 65, 70, 75. Whoopsie. I know how to count. 80, 85, 90. And then go ahead and just make your scatter plot. So just go ahead and get to it. So 3, 65, and just estimate. Try to make it as clear as possible with 5, 80. Very hard to do on a smartboard. 260, 8, 88. Somewhere about there. 6. And then just make sure you have 2, 4, 6, 8, 10 dots. So on the next page it says, write the equation of the line. Well, that means we need our calculator. So you take your calculator, opens up, and we go to Stat, Edit. You're going to clear list 1, clear list 2, and if you have your regression line in there, clear that. You can tell, see I lost my regression, my residual line. We're not going to need it for this, but this calculator does not save it like yours does. I'm not going to go through putting it in because we don't need it for this lesson. So you're going to go ahead and just put the date in. So 3, 5, 2, 8, so forth. 3, 5, 2, 3, 8, 2, 7. And when you hit enter on the last one, you should be in spot 11, but it should be empty. And go to list 2, and put in your scores. And after you hit enter on the last one there, it should also be on 11. Everything should be lined up. You should have 10 X's and 10 Y's. If not, double check. And you should double check your entries anyway, just to make sure before we start calculating that everything matches up. So real quickly, go through and scan your 10 entries and make sure you get your numbers right. Okay, so we're just going to go Stat, Calculate, 8. Make sure we have L1, L2, alpha Y equals, alpha trace, pick Y1, enter, enter. Mine doesn't have the R and R squared. I was telling you what it is. This resets, so I have to reset it every time. That gives us the information we need. So for this one, we have A is 56.11, B is 5.04, R squared is 0.72, which should be on your calculators, and R is 0.85. Unfortunately, this one resets the diagnostics, and you have to turn it off. So that's all this important information should be on your calculator right now. So to write our regression line, we just write y hat equals A, 56.11, plus B, 5.04, X. Now just remind ourselves that Y is scores and X is hours studied. With that information, we look at the slope. Remember, B is our slope. So slope is always y over x, y minus y over x minus x. So that means 5.04 over 1. So again, y is scores, and this is hours studied. So we analyze it. What does it mean? 5.04 for scores, 1 hour study. It means for each additional hour of studying, we predict or we expect, you can use either word you want, our scores to go up or increase, whatever word you want to use, by 5.04 points. So every hour we study, we expect 5% higher, or 5 points higher on our test. That's what we expect. Okay, what is the correlation coefficient? That's right off our calculator. We're done. 0.85. Predict the value of y when x is 7. Y hat equals 56.11 plus 5.04 times 7. We just plug it in. We put 7 in, multiply by 5.04, and then add 56.11. We get 91.39, which means the point, x of 7, y of 91.39. Not important for this problem, but it will be coming up. We're just going to do the same thing here. Predict y when x is 4, so y hat equals 56.11 plus 5.04 times x of 4. Multiply and add, and you get 76.27. Now what does that mean? That means the point is 4, comma, 76.27. Now what does it mean in this study? That means 4 hours of studying, you should get about 76%. But if you study 7 hours, you get 91%. That's what it means. X is studying, Y is scores. Now, it says find the residual for this point, 478. Is 478 a predicted value or an observed value? Well, look at letter E. It says predict the value when x is 4. So this is our predicted value. So that makes this our observed. Now, remember, residual, the more you write down, the better. Residual is observed minus predicted. So, we already know what 4 is predicted. We know what 4 is observed. So all we have to do is take observed, 78, minus predicted, 76.27, and subtract. When we do that, we get 1.73. Now, being that 1.73 is a positive number, is that above or below the line? That is above. Now, this one is not as much done for you because it says find the residual for 266. Well, again, this is our observed, but we haven't already calculated the predicted for 2, have we? So we have to do that. Y hat equals 56.11 plus 5.04 times 2. What score do we expect to get on our test if we study for 2 hours? 66.19. So that relates to the point 2, comma, 66.19. Again, that's our predicted. So how do we find residual? Observed minus predicted. So observed, 66, minus predicted, 66.19, leads to negative 0.19. Being that it's negative, is it above or below the line? It is below. Okay, r squared. We got r squared right off our calculator. R squared equals 0.72. Remember we told you that we're never going to make you calculate S, so we're just going to tell you S. I'm going to give you S right now. S is 6.3. And now we're going to interpret both. Having trouble speaking today. So we're going to interpret both. This is one of those given statements that we just fill in the blank. So we're going to use the same one we did the other day, in the previous lesson. So we're going to do r squared first. We have to change this into a percent. Okay? And we say about 72% of the variability in my Y, which is scores, is accounted for by the, and we can just abbreviate, least squared regression line with X equal to hours studied. So remember, this is the basic statement. The only part that we fill in is here, here, and here. But basically, that's our statement. About some percent of the variability in my Y is accounted for by the LSRL with X being whatever X is. So all you do is fill in the percent, which is just the R squared converted to a percentage. You fill in your Y, and you fill in your X. That's it. Now we're going to interpret our S. Again, same statement. When using the LSRL, okay, when using the least squared regression line, with X being hours studied, and Y being test scores, or if you just write scores, that's fine. Get the gist. We will typically be off by about 6.3 points. And remember, this last part is always our Y. So again, this is a basic general statement. When using the LSRL with, I've got my X here, with X being our studied, so that's a fill in the blank there, and Y being test scores, will typically be off by about 6.3 points. And again, that's our S, which we will always give you. Okay, construct and interpret 95% confidence interval for the slope of the LSRL. So we do our fancy looking B. We make it kind of curvy and cute as you want it to be. And this is our kind of basic statement. The true slope of the line relating X hours to Y scores. Okay? So again, this is one of our basic statements. We fill in this and that. Okay? So it's a true slope of the line relating blank to blank. And you just fill in x and y from the original problem. And here's our last statement of our last notes of the semester. We are 95% confident that the interval now, where do we get our interval? That's from our calculator, remember. So let's get our calculator back out. All of our data is still in there. This is where you go to stat. Instead, you go to tests. You might want to write this down in the notes. Stat, tests, G. And everything's pretty much there. It should be L1, L2, 95%. You just kind of hit enter a bunch of times. And there's our range. Right there. 2.4578, 7.6308. That's where we get it from. And look, notice there is the S, 6.3, but we already gave that to you. So, we're 95% confident that the interval from, let me just get it off our calculator, 2.4578 to 7.6308 captures, and here's where we fill in our B. So this is going to come in here now. The true slope of the line relating X hours to Y score.